In the realm of interspecies communication, there is perhaps no greater cognitive dissonance than the human interpretation of a dog's wagging tail. To the casual observer, the rhythmic oscillation of the caudal appendage is a universal signifier of joy, a biological smile. However, within the framework of evidence-based ethology and neurobiology, this interpretation is not only reductionist, but frequently erroneous. What the human eye perceives as a monolithic gesture is, in reality, a complex motor output driven by competing neurological circuits. The wagging tail is not a happiness meter, it is an indicator of metabolic arousal and emotional conflict. To decode it, we must strip away the anthropomorphic veneer and examine the underlying physiological machinery. We are looking at a byproduct of the autonomic nervous system attempting to maintain physiological homeostasis amidst fluctuating environmental stimuli. The disconnect between human perception and canine reality often leads to a failure in recognizing escalating stress, where a wagging tail acts as a functional mask for systemic autonomic strain. The wagging tail is a mechanical extension of the autonomic nervous system, ANS. When a dog encounters a stimulus, the ANS initiates a cascade of responses that precede any visible movement. Research conducted at the University of Bari by investigators such as Giorgio Vallortigara and Angelo Quaranta has demonstrated a profound lateralization in tail wagging that corresponds to hemispheric brain activity. The canine brain, like the human brain, is divided into two hemispheres with specialized emotional functions. When a dog experiences a positive approach motivation, typically activating the left prefrontal cortex, the tail wags predominantly to the right side of the dog's body. Conversely, withdrawal avoidance stimuli, such as the approach of an unfamiliar dominant conspecific, activate the right prefrontal cortex, resulting in a left-biased wag. This is not a conscious communicative choice, it is a direct reflection of the neural pathways firing in the brain's hemispheres where the cross-wired nature of the nervous system dictates the physical output. Beyond lateralization, the intensity and frequency of the wag correlate with heart rate variability, HRV, and vasoconstriction. High arousal states, often misinterpreted as excitement, trigger a sympathetic surge. This results in tachycardia, an immediate increase in heart rate to prepare the musculoskeletal system for potential action, fight or flight, altered respiratory frequency, a shift toward shallow, rapid breathing, tachypnea to facilitate rapid gas exchange and thermoregulation, blood redistribution, vasoconstriction in the visceral organs and the skin to prioritize blood flow to the skeletal muscles. As noted in studies by the Royal Veterinary College, a high-speed wag in a tense context is often a precursor to a defensive motor pattern. It signals a system under high allostatic load rather than a state of relaxation. The physical movement of the tail helps dissipate some of the metabolic energy generated by the sympathetic nervous system's activation, acting as a kinetic release for internal pressure. To understand the tail, we must look at the hypothalamic-pituitary-adrenal (HPA) axis, the primary hormonal highway of the stress response. When a dog is placed in a state of chronic ambiguity where the wagging tail reflects conflict, the HPA axis becomes the primary driver of the animal's internal chemistry. When the hypothalamus perceives a stressor, it releases corticotropin-releasing hormone, CRH. This signals the pituitary gland to release adrenocorticotropic hormone, ACTH, which travels through the bloodstream to the adrenal glands, triggering the secretion of cortisol. While cortisol is essential for short-term mobilization and glucose metabolism, its chronic elevation leads to systemic degradation. The wagging tail in a stressed dog is often accompanied by a flash of cortisol. This hormone crosses the blood-brain barrier and begins to alter the dog's perception of its environment. Over time, the repeated activation of this axis leads to a state of hypercortisolemia, which suppresses the immune system and disrupts protein synthesis. Researchers at Linköping University in Sweden have pioneered the study of cortisol accumulation in canine hair. Their findings indicate that highly active or excitable dogs, those who wag their tails incessantly in response to human presence or environmental noise, often show significantly higher long-term cortisol levels. This suggests that what owners perceive as enthusiasm is often a manifestation of chronic hyperarousal. The tail, in this context, is a pressure valve for a system flooded with glucocorticoids. The happy wag is, in many cases, a physiological symptom of an overworked endocrine system. The interpretation of the environment is governed by the interplay between the amygdala, the threat detection center, and the prefrontal cortex, the executive center. In a balanced state, the prefrontal cortex exerts top-down inhibition on the amygdala, allowing the animal to remain calm. However, under conditions of repeated stress, this circuit degrades in neurobiology. Cognitive bias refers to the tendency to interpret neutral stimuli as either positive or negative. A dog with a sensitized amygdala will exhibit a pessimistic cognitive bias, even if the tail is wagging. Due to high arousal, the underlying neural state is one of hypervigilance. Studies at the University of Pennsylvania and the University of Lincoln have used judgment bias tasks to show that dogs in high-stress environments interpret ambiguous signals as threats. When a dog wags its tail while staring at a neutral object, it isn't necessarily curious, it is often performing a displacement behavior. This occurs when two opposing drives, such as the desire to approach and the urge to flee, are activated simultaneously. The brain, unable to resolve the conflict, shunts the energy into a repetitive motor pattern, the wag. We must also consider the role of dopamine in the mesolimbic pathway. Wagging can become a self-soothing mechanism. The repetitive movement may trigger a small release of dopamine, creating a feedback loop where the dog wags to mitigate the discomfort of its own anxiety. This is a form of stereotypy similar to pacing in captive zoo animals. The late Jacques Panksepp, a pioneer in effective neuroscience, identified 7 primary emotional systems in the mammalian brain. The wagging tail is most frequently tied to the seeking system and the fear system. The seeking system, driven by dopamine, this system encourages exploration and foraging. A relaxed, broad, fluid wag often signals the activation of this circuit, indicating a dog is expecting a reward. The fear system, centered in the periaqueductal gray and the amygdala, this system triggers withdrawal. A stiff, vibrating, or low-tucked wag is the physical manifestation of this circuit, competing for control. We must also reference the work of Martin Seligman regarding learned helplessness. In scenarios where a dog's signals, including subtle tail positions, are consistently ignored or misunderstood by humans, the animal may enter a state of psychological shutdown. In this state, the tail may wag in a low, submissive arc. Not because the dog is apologizing or happy, but as a vestigial social pacifier. This is the neurobiological signature of maladaptive coping. The animal has learned that its environment is unpredictable and uncontrollable, and the wag is a desperate attempt to inhibit aggression from a more powerful figure. The canine nervous system does not exist in a vacuum, it is a mirror of the human environment. Biosynchrony describes the phenomenon where the physiological states of two species synchronize during interaction. Research has demonstrated that when a human's cortisol levels rise, their dog's levels frequently follow suit. A landmark study involving dozens of dog owner pairs showed a strong correlation in long-term cortisol concentrations. If a human perceives a tail wag as happy and responds with high-energy vocalizations or physical overstimulation, they inadvertently spike the dog's heart rate further, creating a feedback loop of neurochemical, sympathetic activation. This interspecies synchronization means the excited tail wag is often a reflection of the human's elevated emotional state, transmitted through scent, chemosignals, and microgestures. The dog is forced into a state of emotional contagion, where its own tail wag becomes a tool for the human's emotional regulation, often at the cost of the dog's own metabolic stability. What happens when the tail never stops wagging? When a dog is perpetually in a state of high arousal, the brain undergoes structural changes. This is the transition from stress to allostatic overload. Under the influence of chronic stress, the dendrites in the amygdala grow denser, sensitization, while the dendrites in the prefrontal cortex wither, atrophy. This is a physical restructuring of the brain that makes the dog hardwired for anxiety. The tail wagging becomes a compulsive motor tic rather than a communication tool. This process is often irreversible without significant environmental changes.